inverse trigonometric functions, and right triangles. We can use some simple diagrams to enhance our understanding of the range of inverse trig functions. Now, we previously discussed inverse trig functions, and so recall that if you are looking at the inverse sine function, we know that the angle theta must be an angle between pi over 2 and negative pi over 2. For the inverse cosine function, theta must be an angle between 0 and pi. And for the inverse tangent function, theta must be between pi over 2 and negative pi over 2. Now, once we have an angle in a particular quadrant, so for example, if an angle theta is in the first quadrant, we know that sine of theta is defined to be y over r, cosine of theta is defined to be x over r, and tangent of theta is defined to be y over x. And so we can use these simple definitions of sine, cosine, and tangent to help us evaluate expressions involving inverse trig functions. So as a quick refresher here, the inverse sine, inverse cosine, and inverse tangent functions are restricted to the following domains and ranges that you see here. And recall that these functions are also called the arc sine, arc cosine, and arc tangent functions, respectively. Let's take a look at an example. So if I wish to evaluate the inverse sine of radical 3 over 2, one way to do this, of course, is just to think of an angle on the unit circle for which the sine is radical 3 over 2, and the angle, of course, has to be between pi over 2 and negative pi over 2. But what I prefer to do is simply make a simple diagram. So we know for inverse sine, we're going to get some kind of an angle between negative pi over 2 and positive pi over 2. And since it's inverse sine of positive radical 3 over 2, that means that the angle we are looking for is definitely in the first quadrant. Because if it were in the second quadrant, we would have a negative value here. And in this diagram, we know that sine is defined to be y divided by r. So I can label this diagram as radical 3 here and 2 here. And then I could solve for the missing side using the Pythagorean theorem. So for example, if I call this x, we know x squared plus radical 3 squared is equal to 2 squared. That's x squared plus 3 equals 4, which means x squared equals 1, so x has to be positive or negative 1. But in this case, since we're in the first quadrant, we know x must be 1. Now, you can also know that x equals 1 by just understanding the relationship in this special triangle, because we should also know that this angle here is 60 degrees. And so what is the inverse sine of radical 3 over 2? What is the angle that produces this value when looking at the sine function? So the answer here is 60 degrees, or if you're doing the answer in radians, we would say it's pi over 3. For the inverse cosine of negative 1/2, it's the same basic idea, except that now, since we're talking about inverse cosine, we know that angle should be somewhere in between 0 and pi. Now, it can't be in the first quadrant, because if it were in the first quadrant, this value would have to be positive. So we know that we are looking at a value in the second quadrant. And we also know that cosine is equal to x divided by r. So in this diagram here, x would be negative 1 and r would be 2. And then just like we did in the previous example, we could solve for the missing side here and find out that it's radical 3. And then we could also figure out that this angle must be 60 degrees, which means the angle in standard position here would be 120 degrees. So the inverse cosine of negative 1/2 is 120 degrees, or the radian equivalent of that, which would be 2 pi over 3. And finally, for the inverse tangent of 1, we can once again draw a simple diagram. We know that inverse tangent produces an angle in between negative pi over 2 and positive pi over 2. Since this is positive 1, we know that angle must be in the first quadrant. And keep in mind that this is 1 divided by 1. So tangent is defined to be y over x. So both of these sides here would be 1. And that means the hypotenuse here would be radical 2. And of course, this happens when you have a 45-degree angle. So the answer here would be 45 degrees, or the radian equivalent, which would be pi over 4. Now, in the following examples here, notice that these are not special values. And so if you try to solve this the same way we did the previous example, you would say, okay, inverse sine of 0.71, we know that's going to be in the first quadrant, and 0.71 is the same as 0.71 over 1. So this would be 0.71 here, 1 here, and then we can find the missing side. But the real question is, what's the angle involved, right? That's what we're looking for. And we don't know this angle because this is not a special value. So in this case here, we simply plug this into a calculator and we get an approximation. So after doing that, you can see that the inverse sine of 0.71 in radians is approximately 0.789, and in degrees, it would be approximately 45.2. Now, when I plug this into my calculator, I had to put my calculator in radian mode when I did this one, and I put it in degree mode when I did this one. So the answer here is 45.2 degrees, or in radians, 0.789. And the way we know this is radians is we do not put the degree symbol. Now for inverse tangent of 2, this is exactly the same thing. It might look like a special value, but if you go to draw a triangle here, you would have to be in the first quadrant. And tangent is 2 over 1, and then this would be radical 5. And so once again, we don't know what that angle is going to be. So in this case, we plug it into a calculator. And in this case, inverse tangent of 2 in radians is 1.107, and in degrees is approximately 64.4 degrees. And finally, we have the inverse cosine of 2. Now, once again, if you try to do this without a calculator, you would get an angle between 0 and pi. And of course, since 2 is positive, it would have to be in the first quadrant. And we know cosine is x over r. And so if this is 2 over 1, that means r would have to be 1. And you could try to find this side, but, again, we're really interested in the angle here. But look at this picture. Something really doesn't look right about it. And the problem is that if you have a right triangle, the hypotenuse has to be the longest side. 1 is not longer than 2. So this is simply not possible, right? So inverse cosine of 2 simply does not exist. We can use inverse trigonometric functions to find angles and triangles. So if you look at the following triangle, here we have some angle theta, and then this is the side opposite that angle theta, and this is the hypotenuse. So we know that sine of theta must be equal to 10 divided by 50. Now that's the same thing as saying sine of theta is equal to 1/5. And if sine of theta equals 1/5, theta would simply be the inverse sine of 1/5. And now we can plug this into a calculator to get the answer here. Now, when solving for angles and triangles, we almost always want our answers to be in degrees, at least until you get to calculus, and then everything will be answered in radians. But for right now, we'll just answer this in degrees. And you can see here that we get a value of approximately 11.5 degrees. In the next example, a 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle formed by the ladder and the building? So we're looking for this angle here. You can see once again we have a right triangle. And in that right triangle, we have sine of theta is equal to 6 divided by 40. Right, so that's 6 feet divided by 40 feet. This means that sine of theta is going to be, the feet cancel out. And if you divide by 2 here, you get 3 over 20. Therefore, theta will be the inverse sine of 3 over 20. And once again, we'll do this in degrees. And that gives us an approximate answer of 8.6 degrees. In the next example, a lighthouse is located on an island that is 2 miles off a straight shoreline. So we have a straight shoreline here. The distance that the lighthouse is from that shoreline is 2 miles. Now, a distance from a point to a line is always defined to be the perpendicular distance. So we know we have a right angle here. And it says, express the angle formed by the beam of light. So we have a beam of light shining on the shore here. So we want the angle between that beam of light and the shoreline in terms of the distance d in the figure. So if you look at this picture here, you have a right triangle. For this angle theta, 2 miles is the opposite side and d is the adjacent side. So the relationship is that tangent of theta is going to be 2 miles divided by d miles. And of course, the miles cancel out. And so we just end up with tangent of theta is equal to 2 divided by d. Now, they want us to express the angle in terms of the distance d. So we want to solve for theta. So then theta would simply be the inverse tangent of 2 divided by d. And this would be it, because we don't know the value of d, so there's nothing that we could plug into a calculator to approximate here. We can also solve basic trigonometric equations using inverse trigonometric functions. So in this case here, we want to find all angles theta that are between 0 and 180, so they are specifying that theta has to be in between 0 and 180, satisfying the given condition. So sine of theta is equal to 0.4. So now let's keep in mind that if sine of theta is 0.4, in terms of the sine function and the inverse sine function, right, we're looking for an angle between pi over 2 and negative pi over 2 that satisfies this. So we're looking for theta, which is going to be the inverse sine of 0.4, and that's going to give us the angle in the first quadrant here. So let's go ahead and figure that out. And in this case, this is approximately 23.6 degrees. Now, we're looking for all angles theta between 0 and 180 that satisfy the fact that sine of theta is equal to 0.4. Now, let's keep in mind that when you're talking about the sine function, sine is positive in the first quadrant, and it's also positive in the second quadrant. So if one possibility for this is the angle 23.6 degrees, like we solved for here, then the other possibility is going to be the angle in the second quadrant that has the same reference angle of 23.6 degrees. So the question is, what is that angle? Well, that angle, of course, is 180 minus 23.6 degrees, which is going to be 156.4 degrees. So there are two possible angles, 23.6 degrees or 156.4 degrees, because if you take the sine of either one of those, they are going to give you a value of approximately 0.4. And you can see a picture of that over here. Nice picture. Now for the second part, we want cosine of theta to be 0.4. So to solve for where this is true, recall that the inverse cosine function is going to give you an angle in the first or second quadrant. However, we know that cosine is only positive in the first quadrant. So we're looking for this angle theta here. And so theta will be the inverse cosine of 0.4. And let's go ahead and plug that into a calculator. And this is approximately 66.4 degrees. Now, in this case, this is the only solution because we know in the second quadrant, cosine is negative, right? It's positive here, but it's negative in the second quadrant. And since we only want angles between 0 and 180, but it must satisfy cosine is positive 0.4, we know for cosine there can only be one answer to this question. So it is only this angle, 66.4 degrees. Now consider the following expression. Cosine of the inverse sine of 3/5. Now we know that when these trig functions agree, so when you have, say, cosine and inverse cosine, we can cancel them out in some situations. But of course, there is no canceling that is going to happen here. So how do we do this? So like anything else, if you don't know how to do it, always start on the inside and work your way out. So let's look at the inverse sine of 3/5. What is this equal to? Well, let's draw a picture. We know that inverse sine gives us an angle that is going to be between negative pi over 2 and positive pi over 2. And since 3/5 is positive, we know that in this case, that angle is going to be in the first quadrant. Now, if I label this triangle, sine is opposite over hypotenuse, or y over r. And then we know the missing side here must be 4. You can solve for this using the Pythagorean theorem if you want. But we also know this is a very special triangle, the 3, 4, 5 right triangle. Now, do I know what the angle is here? I do not. Okay, so I do not know what this angle is. However, if you think of that angle as being some angle theta, then the cosine of the inverse sine of 3/5 is just the cosine of that angle theta. And if you look at this picture, cosine of that angle theta is x divided by r, right? We know it's 4/5 because that's how cosine is defined. So in this case, we never actually know what this angle is, but we also don't need to know what that angle is, because it's not really the angle that we're looking for here, it's the cosine of that angle. And finally, we can evaluate similar expressions involving variables. So here we have right sine of inverse cosine of x and tangent of inverse cosine of x as algebraic expressions, so that x is some number between -1 and +1. All right, so again, if I want sine of inverse cosine of x, I'm going to start by saying, what is the inverse cosine of x? Well, inverse cosine of x is equal to some angle, and we know that angle is going to be between 0 and pi. Now, depending on whether x is positive or negative, you could have a triangle here, or you could have a triangle over here. There's two possibilities in this case. Now, inverse cosine of x is some angle means that cosine of that angle equals x over 1. So this has to be x, and the hypotenuse has to be 1. And then we can solve for the missing side here, which I'll call y. We know x squared plus y squared must be equal to 1. So if you solve for y, you're going to get y is equal to plus or minus the square root of 1 minus x squared. Now we can see that y is positive because we're in the first quadrant here. So we know it's positive square root of 1 minus x squared. And it's also the same thing over here. So now we just want to know, what is the sine of this angle? So the angle I'm talking about, of course, is this angle here or this angle here. Well, we know that sine of an angle, if you have a picture, is opposite over hypotenuse, or y divided by r. So sine of this angle is going to be the square root of 1 minus x squared over 1, which is simply the square root of 1 minus x squared. And then tangent of inverse cosine of x, it's the same exact diagram. Tangent is this value divided by this value, right? It's opposite divided by adjacent. And so that is going to be the square root of 1 minus x squared divided by x. Now, I pointed to this diagram, but this diagram here gives you the exact same thing. And that concludes this video lesson.